In the previous nugget of this course, we looked at virtualization inside a network device. We're going to do something pretty similar in this nugget, but our focus is going to be on storage. You might not have realized it, but what is so common in storage area networking is indeed storage virtualization. You see, we have physical disks and a wide variety of physical disk structures of normally great sizes. And then what happens is virtualization kicks in order to represent a portion of that actual physical space as a logical disk for a particular server system to use. Now, there can be multiple layers of this virtualization, and what's really interesting, and my main focus in this particular nugget with you, is there are indeed multiple ways in which to carry this out. What do I mean by that? Well, for instance, are we going to have the host in charge of that virtualization? Doing this storage virtualization in the networking equipment. Couple of different approaches I'll show you, and this is our emphasis. Now, without the bias of Cisco systems, we really must admit that there are tremendous, powerful advantages to having the network equipment do this virtualization, and I'll spell those out for you later in this nugget. Now, how do we identify the logical disk, which we know in the backdrop has an actual physical counterpart? Well, in storage area networking, we identify this logical disk with a LUN. That stands for logical unit number. And you know what we do? We get really lazy and technically inaccurate with the terminology. We tend to just call the logical disk itself the LUN. Yeah, so we get kind of lazy there, and we refer to that logical disk as a LUN. But technically, the LUN is just a numeric identifier assigned to that logical disk. Now, one of the challenges with a LUN, right, this logical disk, and now I'm going ahead and being lazy and using that terminology, but so one of the challenges with the logical disk is the fact that we want to control access to it. For example, we don't want multiple servers writing to it simultaneously and perhaps corrupting some data. So in storage area networking, there are several approaches to solving this. One technique, one array-based technique, is for the particular enterprise disk system to go ahead and do what's called LUN masking. Yep. LUN masking makes sure that the logical disk is only available to certain servers identified by what's called their port worldwide name, or PWWN. And by the way, if you're brand new to storage area networking, have no fear, we'll be getting involved in much greater depth in this later on. But just so you know, an array-based solution would be to LUN mask and to only portray logical disks to the appropriate ports out there that our servers are connected to. In addition to LUN masking, there is the capability to do LUN mapping. We find LUN mapping done in fiber channel environments. The administrator comes along and selectively maps logical disks to particular host bus adapters in servers. Cisco invented. So it's nice in what we call heterogeneous environments where we have equipment from many different vendors. So let me really map out this broad topic of storage virtualization for you. When we talk about block storage virtualization, we're talking about what I was referring to a moment ago. We're really zeroing in on the fact that we can provide a logical volume to a user that is actually stored somewhere physically. That aspect of virtualization we refer to as block storage virtualization. When we speak of disk virtualization, we are speaking about presenting to the user a disk out of a large array of disks. Obviously, when we talk tape virtualization, we're talking about making a logical tape drive out of a virtual tape library available to a particular system. File system virtualization refers to literally allowing a user to access a particular file that is in a logical presentation when that file might be in some far off remote physical location. And then finally, file and record virtualization refers to the presenting of a logical volume to a particular user, again, independent of the physical location of that particular storage. So lots of different ways in which to describe the specific virtualization that we're dealing with. As I made clear, we can do it at the host level, the network level, or the array level, and we can do it in band or out of band. Now, what does this mean? Well, it means, are we going to separate the control traffic that has to do with the virtualization? Or are we going to just go ahead and let that run in parallel paired with the data itself that we're moving back and forth? What do you think is preferable in most situations? Well, it's to do it out of band, and this is an approach that Cisco will often take. So we have the data going across in one channel, and then the control related information that controls the virtualization itself being carried through a separate and independent path. This really helps with bottlenecks that would occur due to the virtualization of storage. Now, I could put together or attempt to a long laundry list of why Cisco really touts network-based storage virtualization. That, of course, is storage virtualization handled by something like an MDS switch. But let me just really boil it down to you into one main advantage. That are specialized in doing it is really going to have big time performance and scalability advantages. You know what time it is? It's exam time. What storage technology was created by Cisco to control initiator to target communications in a fiber channel network? ACLs, LUN zoning, port security, or LUN fencing? And I'm so glad this question came up because we are talking storage technology and we're talking initiator to target, we're talking fiber channel. And at this point in our course, you might start to panic because we haven't really discussed fiber channel networking in depth yet and what we call fiber channel initiators and targets. But look, we can arrive at the correct answer here based on this nugget. We know a lot about storage technology now, and we discussed a particular Cisco invention. You remember? It was LUN zoning. We contrast this technology to LUN masking and LUN mapping that we talked about. Yeah, LUN zoning is that specific proprietary technique that Cisco offers in its MDS switches, which allows us to take our LUNs and selectively zone them to appropriate host ports. So great work, everyone, in this nugget, and excellent work in this exam time break. I hope this has been informative for you, and I'd like to thank you for viewing.